Hello, welcome students. In the previous lectures, we are just finished the topic number 12, magnetism, and in this lectures, we are just started of the topic number 13, the electromagnetic waves and communication systems. I hope all are you happy and to start with the happiness minds of the new topic, that is topic number electromagnetic waves and communication system. These electromagnetic waves are studied just for the informations or just for the introductions in the topic number. I don't like the topic say to topic number, that is exactly name of that topics sound. When we are studying what are the waves, propagations of the waves, types of the waves, they will be studies electromagnetic waves, matter waves, longitudinal waves, transverse waves, lot of waves will be studied in the topic sound, but they are not studied in the detail or in the deep. But in these lectures we are studying in these topics we are studying the electromagnetic waves. What are the electromagnetic waves, some basic informations, and we are studied deeply the electromagnetic waves and what are the uses of the electromagnetic waves in the communication systems. Okay, when we are take the topic of the communication systems, we know the televisions, cell phones and any other systems, they use for their signal transmissions, for communications, they use the electromagnetic waves. Then these lectures or this topic's name is electromagnetic waves and communication systems. But now let's start to introductions of the electromagnetic waves, EM waves. What are the EM waves? EM waves. And the describe EM waves, we are just revisions what we are studied in the previous lectures or in the whole physics when we are started to studying it. Then the electromagnetic, four basic laws to describe the relationship between electric field and magnetic field and their generations by the charge and current. Four basic laws, it is mainly four laws which describe the relationship between the electric field, that is E bar, and magnetic field, that is B bar, by their generations. How will be generate the electric field and magnetic field, and they give some laws of the relations between the electric and magnetic field, their generations by electric charges and current. When the current will be flowing conductors, the magnetic field will be produced around the conductor. This is the right hand thumb rules. Then we are just discuss the one by one these four laws which can be give the relationship between electric and magnetic field years. Then let's start to discuss the laws. First laws we are discuss previous, that is law first, Gauss law of electrostatic. Gauss law for electrostatic. In the electrostatics we are describe the one laws, we are explain, we are understand the one of the laws. This law is called as Gauss law of electrostatics. When the net electric flux is proportional to the net electric charges, this is the state of the Gauss laws. But the Gauss law of electrostatics, which is essentially same for a Coulomb's law, which is essentially same for Coulomb's law. Coulomb's law is also related to the charges Then they gives the force of attraction between the charges. Then Coulomb's law. Then it is state that they gives the relationship. This law will be describe the relationship between the static electric charges. That is, static electric charges means charges will be steady. And this law describe the relationship. Describes the relationship between static charge and produced electric field. Static charge between and electric field produced by them. This is the relationship between the static charge and electric field, that is E bar, produced by these charges, that is produced by them. This is the first law, Gauss law of electrostatic. We write the second another law. This is Gauss law for magnetism. Gauss law for magnetism. We are just discussed the informations about the electromagnetic waves. What are the electromagnetic waves? How they are propagated? We are just discussed. Next, the source of the electromagnetic waves. We are just discussed the next lectures, lecture number 2 of these topics. And characteristics of electromagnetic waves and some different types of the electromagnetic waves are discussed in the half top of, that is electromagnetic waves. In the communication systems, we are just discussed the different types. Then Gauss law for magnetism, which is similar to the Gauss law of electrostatic. We know that we are studying in the previous topic, that is Gauss law of magnetism. They are also similar to the Gauss law of electrostatic, but the net magnetic field will be 0, but net electric field is proportional to the electric charges. The Gauss law equations for the Gauss law in the previous topic we are just discussed here is equal to 0. Net magnetic flux is equal to 0 is said. It is the statement of the Gauss law for magnetism, which is similar to the Gauss law of magnetism, which is similar to the Gauss law of electrostatic. It states that the magnetic monopoles magnetic monopoles strength of the, it states that the magnetic monopoles which are throughout the magnetic charge, which are throughout thought that magnetic charge and magnetic charge equivalent to electric charge does not exist. Electric charge does not exist. We are just discussing in the previous topic, that is Gauss law for magnetism. This is the law number 2, and law number 3 will be here. Law number 3. This is both law are according to the only Gauss laws. The first law, Gauss law of electrostatic. Second is Gauss law of magnetism. And what are the statements and what are the main purpose to these laws? They gives the relationship between static charges and electric field. This is in about the Gauss law of electrostatic. Gauss law of magnetism, they gives the equivalent relationship is does not exist. The electric charges and magnetic charges are not equivalent. The third law, that is the Faraday laws. Faraday law. I'll be said one of the things, when the current will be flowing through the conductors, then current will be change in current, then with respect to time they produce the magnetic flux di by dt is equal to phi. And when we are changes the magnetic flux, EMF will be induced, EMF will be produced in the given conductors or given circuit. And this law is about the electric, this is the EMF, induced electromotive force, which gives the relationship between the EMF induced in the circuit and change in a flux. This law gives relationship between EMF produced electromotive force is induced in circuit is and flux, change in flux of same circuit. This is the third law. They are gives the relationship, four laws which is describe the relation between the electric field and magnetic field. When the current will be flowing through one of the conductors, current will be remains changes with respect to time. Current will be slightly changes with respect to time. The the magnetic flux is produced here, but magnetic flux is also changes with respect to time, then EMF will be induced, and this law is called as Faraday's law. Then law number 4, it is the law number 4, Ampere's law. It is gives the relationship between induced magnetic field associated with the loop and current flowing through the loop. It gives Ampere's law. Ampere's law. This law gives relationship between induced magnetic field, that is B bar, associated with the loop, this law is associated with the loops. It gives the relationship between the induced magnetic field associated with the loops and current flowing through the loops, and that is current flowing through it. This is the 4 laws which gives the relationship between the electric field and magnetic fields. But some difference, mistakes in the Ampere's law is noticed by the that is James Clerk Maxwell. It is noticed some mistakes in here, and they notice that the magnetic field is generated, not only electric current. In the Ampere's law, it said that magnetic field will be generated or induced with the current flowing through it. But the Maxwell is said that, or noticed that, the magnetic field B bar is generated not only by the current but also electric field. Okay, but also electric field. The Maxwell it said that James Clerk Maxwell is noticed that the produced or generations of the magnetic field is not only depends, or magnetic field is generated not only by magnetic field is generated not only by electric current but also electric field, that is E bar, electric field. This is stated by the Maxwell, that is James Clerk Maxwell. In 1861, they describe one another laws. This is called as the displacement current. Describe one terms is called displacement current. It's called displacement current. They are stated by the James Clerk Maxwell. We discussed lot of the equations. They are combinations of each electric and magnetic fields, shows the relationship. We are discussing in the next lectures. They are called as Maxwell equations. They mainly 4 Maxwell equations. They show the relationship between electric field and magnetic field. In these lectures, we are just discuss the basic informations about the EM waves and 4 laws which can be shows the relationship between electric field and magnetic field here. I will be just revise one by one laws before the rubbing or removing of this on the board. Gauss law for electrostatic, which is gives essentially like the Coulomb's law to describe the relationship between the static charges and electric field produced by them. Charges मुळे electric field जे काही प्रोड्यूस होतं आणि त्याचबरोबर तिथं चार्जेस सोबत असलेलं रिलेशन दाखवणार म्हणजे Gauss law for electrostatic. Second Gauss law of magnetism, it states that the magnetic monopoles which are thought that magnetic charges equivalent to the electric charges does not exist. This is the second law, and this law of Gauss law of magnetism we are just discussed, and the both law will be same, Gauss law of electrostatic and Gauss law of magnetisms. Then the Faraday's law, this law will be gives the relationship between the EMF is induced in the circuit and change in a flux, and it is depends upon the change in a flux of a same circuit. Then how will be produced the flux, that is change in current with respect to time, then produce the electric flux. Then Ampere's law, this law is gives the relationship between the a magnetic field induced in the loop by the current, and they gives the relationship between current and induced magnetic field. But the Maxwell is noticed some mistakes in the Ampere's law, and they say that the magnetic productions of the magnetic field or generations of the magnetic field does not depends only for the electric current. This also depend for the electric field, and some terms will be described in 1861, and this terms is called as displacement current. And let's describe some another scientist what are the says about the electromagnetic waves. ठीक आहे, काही शास्त्रज्ञ काय म्हटलेले आहेत फिजिसिस्टनं इलेक्ट्रोमॅग्नेटिक वेव्ह बद्दल, ते आपण या ठिकाणी आपण डिस्कशन्स करणार आहे. द फर्स्ट मॅक्सवेल नंतर कोणी काय म्हटलेलं आहे, देन वन ऑफ द नेक्स्ट सायंटिस्ट इन 1888 H. Hertz, the name of the scientist, they producing and detecting the electromagnetic waves. They will be produce in 1888, that is H. Hertz. H. Hertz is one of the scientists. They are producing and detecting electromagnetic waves, that is EM waves, and they give some properties about the electromagnetic waves or demonstrations about the properties, demo of their properties that is reflection, refraction and interference. This some property will be described by the H. Hertz in 1888. They are produce and detect of the electromagnetic waves and gives some demonstrations of the properties, some properties. Now let's start to interesting part. In 1896, one of the greatest Indian physicists, Sir Jagdish Chandra Bose, is produced the electromagnetic waves. The ranging of their wavelength is 5 mm to the 25 mm. That is great Indian physicist, great Indian scientist, that is Sir Jagdish Chandra Bose. Sir Jagdish Chandra Bose will produce EM waves, and range of their wavelength is 5 mm to 25 mm. The range of their wavelength is 5 mm to the 25 mm, and its works is confined only laboratory. हे फक्त laboratory मध्ये केलेलं काम होतं. ठीक आहे. त्यानंतर अजून एक सायंटिस्टनं इन सेम इयर इन 1896, तर त्या इट इज इटालियन फिजिसिस्ट फॉर जी मार्कोनी. It is Italian physicist, that is G. Marconi gives one of the important, and they have a Nobel Prize in the physics by this work, that is they established the wireless communications. They are established wireless communications by the Italian physicist, that is G. Marconi, and they give a prize, that is Nobel Prize in this work, that is they are established wireless communications. This is all about the first lectures of the electromagnetic waves. And what are the electromagnetic waves, what is some laws we are discussed. They will be shows the relationship between electric field and magnetic fields, and some scientists are described what are produced, detect by the electromagnetic waves, and someone will be shows the law properties of the electromagnetic waves. Someone will be shows the range of their wavelength, okay, and someone will be shows establish the wireless communications with the help of electromagnetic waves. In this next lectures we are just discuss the source of electromagnetic waves, and I will be challenging you. We are just discuss the 4 different equations, that Maxwell equations, They are shows also relationship between the electric field and magnetic field.